build fluent builders like this can get really complex. And the code to implement them is really quite ugly. But the usability of creating messages through fluent builders is quite nice. So full duplex. This is one scenario that we're going to look at some code for. Full duplex is what you would consider synchronous RPC. But what it really is it's a series of two one-way messages with a callback. And this is an example of how this is performed. Oh, I don't have a mouse. You can see, so the client puts out in its outgoing queue a message, and the server is going to pick up that message, process it, put a message back out here that the client's going to pick up. It behaves and looks just like synchronous RPC, although it's really not. It's a series of two one-way messages. The other one that we're going to talk about, and probably the most common scenario that you see in distributed messaging systems, is publish subscribe, called PubSub for short. This is one-way asynchronous fire and forget messaging. This is where you publish a message and they go on about your business. And there are just an immense amount of examples about publish and subscribe. If you think about, like one piece of code that we'll look at is an audit service. And what happens is somebody goes in and they authenticate through some sort of SSO mechanism. We want to audit that. What happens is the audit request is published, but the authentication server keeps going. It doesn't care what happens to the audit message. It's not its responsibility anymore. And you'll look, when we start looking at unit tests and stuff like that, you're going to see that testing this stuff people think is really, really complicated, but it's not. Unit test integration for this stuff is extremely easy. You just have to think about the concepts and the ownership of the data and the ownership of the behaviors. Most of the time in unit tests, all you can do is verify that you publish the right message. Because beyond that, it's the responsibility of the bus, it's the responsibility of MSMQ, it's the responsibility of some other system that's going to pick it up. And because we're doing reliable messaging and transactional messaging, you can be assured that eventually the system is going to be back into be in a consistent state that you made a request for. And we'll talk about some inventory and order placement examples around this too, to help it make it a little bit more clear. Subscribers subscribe to an explicit endpoint for a specific message. Man, there's a lot of S's in there. And that's done through configuration. Configuration in XML. Configuration in XML around distributed messaging system is configuration that administrators have control over. Things that you have control over are things that surround the bus itself as a developer. And that's done through configuration builders in code. But as far as where endpoints reside, those types of things, and we'll look at the XML files for this stuff. That's the responsibility of administrators. They get to make those decisions about where the endpoints are, where the queues are, what remote servers are doing what, and those types of things. So administrators are allowed to go in and change the XML. But there's things that you have configuration control over too, and that's done in code. Subscribers, when they subscribe to a particular message, they're putting something out on a queue that says, I want to subscribe to this message. And somebody else is looking for that. There's some other bus that's sitting around looking for subscription messages. It's going to pick that up, and it has a return address in it. So the publisher knows, okay, they want this type of message. So every time I publish this type of message, it needs to go to this place. So you can have 100 different subscribers all subscribing to the same message, all going to different places. CommandQuery Separation. This, again, in ERPs, this is quite popular. CommandQuery Separation is very common scenario for PubSub implementations. Commands are, your inserts, your updates and deletes, and queries are what they are. They're queries. If you look at this example, you can, don't have a mouse. You can see that the application is using regular request response here. And what it may be doing is adding a line item into inventory. Well, this is going to, or let's say you bought something. You bought something, so it's going to go into this system, which is a command system. This is a transaction system. It's a database specifically designed for handling transactions. And in a CQS scenario, updates and deletes are very rare. What this is doing is recording a transaction that changes the state of an object. But when that's done, when that transaction completes and that transaction is successful, this is asynchronously going to publish another message that somebody else is listening for, and then it's going to respond back to the application. And while it's responding back to the application, this thing picks it up and says, oh, they have now gone in and changed the state of this item. Well, all queries come through this database, which is typically a star schema database. So this has the changed information, and this is going to make an update into this system, because this is where all queries are coming from. This is a transactional system, this is a query system. So the command database will have, I mean, you can essentially create a new instance of an object. And because that command database has all the inserts around that object, you can essentially roll an object up to its current state, or roll it up to any given point in time to a specific transaction. And that database will eventually get very large, and that's when you do snapshots and purges and those types of things. But the current state is always represented here. This is where everybody's going to get their information. These are two totally different systems. Those are two different service boundaries that exist between these two. I mean, this one's supposed to be highly transactional. That one is not. And some of the problems people have with that is, I placed an order, and they know they placed the order, and the response is coming back here, it says, your order's been placed. Well, the problem here is you go in and look, well, it may not have been here yet, but we're only looking at the most, maybe 2 or 3 seconds of difference. So it's not real time. Nothing's ever really real time. Everything is just always eventually consistent. And eventually consistent is a business rule. If you think about stock tickers and stuff like that, they always say, they're 15 minutes behind. All those transactions that are happening on the stock exchange, they're all going into a system like this. But they're being queried out of a system like this. So this knows this is real time, but you can't query this system. It's too difficult. It's too much strain on that system to do the hash joins and all those types of things to put that data back together for display. All that stuff is maintained here. This is typically what you'd find third normal form. This is typically first normal form or second normal form. It's much more flattened out, designed specifically for querying. But the whole point is to get eventually consistent. Eventually consistent, 15 minutes might be acceptable, or 2 seconds might be acceptable. Eventually consistent is a business rule. Awesome, we're done with slides. Before we get into that, now here is a sample. This is a sample project from in-service bus. And this is the PubSub example. And we're just going to run this real quick, and then we'll start looking at the code for it. Geez, we already... Man. Here I have 2 different subscribers. In here I have a publisher. And when I hit enter on here, you can see that it published this message. And there's